don't trust the wall clocks. Yeah, good afternoon. Welcome to my presentation about the SmartComponent Library. SmartComponent Library is our developer framework. It provides multiple front-end options, leveraging the same back-end business logic, and we're using it in a number of modernization projects with our customers. I'm Mike Fechner, work for my own company, Consulting Werk, in various roles there, from the director to product manager of the SmartComponent Library and other tools, but I also very often, and that's actually the majority of my time, still work with customers, supporting them in modernization projects as an architect. Using Progress for quite a while, which actually helps a lot, because when we try to support our customers in modernization, well, we need to understand how applications have been built over time, and we'll also have a good understanding about how a modern OpenEdge application should look like so that it's future-proof. We at Consulting Werk, we're an independent IT consulting organization. We focus on OpenEdge. That's really the key area of expertise for us, but also related technology, like front-end technology, .NET in various configurations, or web technologies such as the Angular framework. We're based in Cologne in Germany, but we do have subsidiaries or colleagues working from home offices in the UK, in the United States, and in Romania. And from there, we're working with customers, well, almost around the whole world. Majority of the customers, of course, in Europe, but we have a couple of customers in North America, Australia, and South Africa. So we're really experienced working with customers remotely, but well, also on site. We started as a consulting organization, so providing our expertise and knowledge and well, time as developers, but with tools such as SmartComponent Library, we've ourselves become more like a software vendor, focusing on developer tools. A couple of areas that we have a lot of experience in, GUI for .NET, when it was released, I think we've been referred to as the official go-to guys for GUI for .NET, but also other areas, Angular for web applications, object orientation with OpenEdge, software architecture. I think that are areas where we have quite a good reputation, and we use that in modernization projects with our customers. We do not only work with OpenEdge, but majority, quite a wide range of products from Progress. I think over the past years, there have been more. Those are mostly the snapshot from the recent projects. So ABL, developer tools, app servers, everything that OpenEdge has to offer. Telerik and the OpenEdge Ultra controls as front-end technologies for the desktop clients. We use Sitefinity both for our own website. That might not be the best reference, but we've also supported customers in integrating the Sitefinity content management system with OpenEdge backends to provide data from an OpenEdge backend into Sitefinity, or get data into OpenEdge out of Sitefinity, and so on and so on. And besides that, there's a probably even longer list of other products that we use in our services. We use Protop for database monitoring. Listen Label is a reporting product, very popular. And read it yourself. DevOps is becoming more and more important. So as part of modernization projects, we support customers frequently in introducing DevOps technology, starting from build pipelines, but also using Docker. We use Docker ourselves for automated testing of functionality in the framework. So whenever a developer commits code, automatically a Docker container is created with the latest backend code so that we can run unit tests against a working application server. And similar things are provided for customers as part of the the modernization projects. So I want to give an overview of the Smart Component Library in this presentation, talk about back-end, front-end. Probably not going to really talk about native script mobile clients here. And then I'm going to skip some things and we'll actually focus on modernization, some of the tooling that we offer for actual modernization of existing Progress GUI or TTY applications. So let's start with a brief overview at a glance. So the Smart Component Library is a framework built to support OpenEdge modernization. And of course, we provide the backend and the front end. We refer to it as a full stack modernization framework. I've learned recently that we are more recognized for our backend. We are very proud on our backend, and our backend can be used in many different configurations, also without our front ends. But we actually do provide front ends too. Within the development of modernized applications or modern application, we can support the needs of different developers or different needs of developers. There are use cases where utilizing more relational concepts for dealing with data are beneficial, but more and more our customers are using object relational constructs that we provide as part of the framework. That has something to do with use cases and flavors and a combination of both. We provide for all our backend business logic RESTful interfaces. They just need to be annotated and then they work out of the box. And like I mentioned earlier, we have various front-end options for the desktop, for the web, and for mobile applications. The Smart Component Library provides a lot of components that just provide architecture. So if you look at front-end service interfaces, data access, business logic layers, these kind of things. And besides that, we have an application framework that's optional to use. Basically, everything in the framework is optional to use because it's all loosely coupled. It works tightly integrated if you want it, but you could leave everything out or combine it with components that you might have as part of your legacy application. And so some of these optional components are things like authentication, authorization, localization, menus, workflows, and many, many more features in that area. The framework has since day one been designed to integrate with existing applications and frameworks. We can integrate with standard frameworks like maybe Progress Dynamics or DWP or whatever, but also with frameworks that customers may have built for their own needs, so in-house tailor-made frameworks. When we provide a tool for modernization of applications, we do not want to lock our customers or bring our customers into a vendor lock-in with us. That might sound like a commercially interesting aspect for us, but I know that a lot of our customers have chosen us because we provide full source code, we provide full insight into the framework, so that customers are really independent from us in keeping applications alive that once have been modernized with the framework. So customization is very, very important. We currently support the framework on OpenEdge 11.7, 12.2, and 12.5, and plan to provide commercial support for the framework on 11.7 and 12.2 for as long as they're long-term supported by Progress Software. We will be slowing down the new feature support on our 11.7 version, but if customers run into issues, we will help them for as long as Progress supports the underlying OpenEdge versions. If we look at a developer framework, there are many components and many vendors have a different interpretation of a developer framework. For me, a framework starts with a development methodology, so a recommendation how developers should write application and, well, ideally a proven methodology. And then we provide templates around that just speed up developers, tools that may use the templates to actually build application running out application components out of it. APIs and base classes are generally parts of the product that reduce the amount of code that the developer actually has to write because they can leverage functionality that we've built. APIs base classes are mainly used for components that developers write with pre-built runtime components that could be used either as a starting point or in the final solution of an application. DevOps tooling becomes more and more important. We have our own unit testing framework that integrates much better with the framework. With starting points for build and deployment routines that can be adjusted to the needs of the customers. We generally try to be a step ahead of the needs of our customers. So it happens quite frequently that a customer says, hey, we need this in the future. Have you already thought about it or actually done something like that? And luckily, very often we can say, yeah, we actually already built a prototype or we have an idea about that. That might be a new UI technology, like maybe Microsoft's Blazor and Razor was one of the recent cases. Then we can actually provide a solution or at least some ideas for that. The framework is supported as a product. We provide maintenance. We provide frequent releases up to weekly. For us, the release process of new versions of the framework is fully automated. We could actually, after every finished feature, release a new version. The one thing that typically holds me back is finding the time to write release notes. That's something that is hardly automatable. We have testing tools that we use internally that we provide to our customers. We provide training and documentation. SmartComponent Library is present on the training curriculum of Progress here in Europe. There's a next training course that we're planning together with Progress at the end of November, beginning of December. We have a set of best practices, recommendations that we provide to our customers, and an ecosystem that's a group of partners, organizations that could provide consultants or developer resources that have experience with the framework. There are a couple of third-party products from the OpenEdge community that works particularly well with the SmartComponent Library and where we and the vendor of these tools work together in making sure that they integrate nicely. The backend is a very important part of the product. Why is that? I believe that the most modern front-end technology today will be outdated in very few years. Whether I say 3 or 4 or 5 years, pick a number. But the backend and the business logic is typically the thing that less frequently changes and less frequently needs to be modernized. And I believe that once an OpenEdge application has been migrated into our architecture, from a technology point of view, the application will need very, very few changes in the future. I mean, there will always be changes required in the logic, but no more in the architecture. And that's why we put so much effort into tooling around the backend and the architecture there. We follow certain standards in the OpenEdge community. We follow the principle of the OpenEdge reference architecture. We follow the common component specification. We've actually been active member of the group of companies that released the common component specification. We have tooling support there to build the typical backend components like business entities and business tasks. And like I mentioned earlier, in either a relational or an object relational fashion. And we provide then the RESTful services out of the box. That is a tool to build backend components. It can also be used to create front-end components. I'm actually going to show that live. It's our business entity designer. The tool itself has been written in OpenEdge. That's also another key aspect of the product. We are targeting OpenEdge developers, and we want to provide them customization capabilities, not just for the runtime components of the framework, but also of our tooling. And therefore, it makes a lot of sense to use OpenEdge then also in the tooling. The business end designer that I'm starting here currently is available as a GUI 4.NET desktop-based application. We're in the process of porting it as an alternative into the web browser. That's been going on for a while, and relatively positive that by the end of the year we can release the first version of that to our customers. The main workflow of a developer when building a back-end business logic component is done by drag and drop in this tool. So when we generate code and then we add the actual business rules to this tool. It is a bit like an ER diagramming tool. And what we actually built there is a pro data set in a graphical way. I could add multiple tables, drag relations between them. I can add custom fields there. Then work on the details of that field. If it is a calculated field, a field which is being populated by business logic and not by direct access from a database table, we could write the expression directly here. Something like that. And then it would become part of the generated code. For more complex expressions, we're not trying to mimic a development environment in this tool. Then we generate code, let developers work in the real development environment of choice, Developer Studio, Visual Studio Code, whatever, and make sure that when the model of the component is updated, that the changes to the model and changes to code are being merged together, so we have a round-trip development process in place. What I can do is I can, after I've picked an output folder for the component, generate the code. The model is saved to a file. What's wrong with the, oh, picked the wrong table. I wanted to use the order line table. It didn't find a database table that between those tables, it didn't find an actual relation. That's why we got a validation error to save us from having to debug it at runtime. Now I should be able to generate the code. And the generated code is then opened in the Developer Studio so that I could immediately start making changes to it. One of the things that we see here is the calculated field expressions that I put in earlier as being part of the generated code. It is, in the end, a graphical tool to generate code. Before I start editing the code, I can use some of the integrated testing capabilities. Could just run it here, could see if the queries I'm using there, and I haven't really used much complicated stuff there, and the calculated field expression actually look like what they should be looking like. Get that bigger, like that. So I see customer name and city being appended to each other, nothing really complicated. This tool has a couple of other capabilities which are very valuable. When developers start moving away from building just Progress TTY or GUI applications, where basically every developer was a full stack developer because every developer was building front end and back end. It was quite easy. If that screen didn't perform well, you could only blame yourself because you were the only one. But in distributed applications, it might be that multiple developers being expert in different technologies are involved in that. And then it is quite important to understand whether or not this backend component that we just generated is performing well. And when I run a query here that is actually returning useful data. And we've seen there was a slight delay, but I have a relatively fast laptop, so the delay actually isn't that what should scare me. I see that this query did execute or did access 200,000 records. And that's certainly something that you would never want to have in a production system used by multiple users. That would not be performing well. And I can look into more detail. We've integrated the user table and statistic, and we see that this actually had access to 201,000 customer records. So if I enable in the request also the order table, then we would be seeing that now there are also order records appearing there. So we provide, wherever it makes possible, developers support in understanding runtime behavior and debugging the application. And I've used the component now here in our graphical testing tools. One of the things we can also do quite nicely. If I create a procedure, name isn't really that relevant. I can show how we could use the code that was generated as part of this component to actually access the data and the custom business logic from your own code. Just have to pick the right one, this here. Should be adding a period there. So what this does, it generates around, together with a business entity, we generated a model class. Model classes are in application architecture, typically classes that represent data. And as part of the construction of that object, I can provide the primary unique key value, because that's very often used for accessing data. And when I execute that, then Developer Studio is in a good mood. Then I see a message with the two fields here. And if I look at the code, it is actually not more code that I have to write than the find customer, where customer equals 1 and display of these fields. So it's pretty efficient way of coding. And if you say, well, I need access also by searching for records, then you just not provide the primary unique key values, and then you can write a query using the filter capabilities there. You can use IntelliSense or code completion along the way, something like that. That will create a dynamic query, but in a way that you cannot do a typo, because all of this is compile time validated. And if I execute that, it should actually return the same record. And that's one way how we can access the business logic component. So the business entity that we generated is responsible for reading data, but also for containing central validation. We could use this for updating records. And if it's so easy to use that component and actually protects developers more from making runtime errors than if they would do dynamic queries and all that themselves, then no developer will have an excuse to not use the standard components and would have an excuse why he would ever have to build another component that accesses components. So code redundancy, which is a big problem for maintainability, something which we can avoid by making it very easy to access these these components. And at the same time, the business entity that we have generated here, and well, could show some of the code. There's a pro data set and all that, so really standard ABL code, can also be used as a REST service. And REST service is something that is just the standard these days for providing data from one application to another application. So we can make that also very, very easy. I'm going to use a business entity that I've prepared. Well, it's the wrong one. And in that business entity, we do have a set of annotations. That's our own style of annotations that developers can put in the code. And they just declare how this component should be exposed as a standard RESTful service. And I can use that, just start a web browser. I authenticate to the app server, and with this address /customer/1, I'm actually addressing an address which is declared by this annotation, customer/1. It's some of the standards for semantics with RESTful interfaces say that even if you're accessing a single record, it should have a plural noun, and then the key values, I could also look for a list of records. So now I have the first, I think, 10 records, what we're exposing by default. And we see as part of the annotations, we can also declare links to related data. And we see them also as part of the response. So I see a few fields of the customer record, the address of the customer record, and then related information, which basically would be running a query on the orders or the open orders for that customer. Makes it very easy to navigate the data, and using a real REST client, we could use this interface also to update the data. And the thing with these links, you may ask if you never looked at those, that's the standard called HTOS, hypermedia as the origin of application state. The idea behind that is we as the backend providers tell a consuming application how to, or where to consume related data. We provide the links to that. We don't write specification and say, hey, if you want to have the orders for this customers, put together this link yourself. No, we provide it. And then it's very, very easy to consume that. And even if we have to change something here, in every response, we provide the updated addresses to related data, and make it, almost impossible to consume the data in a wrong way. All these RESTful endpoints, they're documented using a standard tool called Swagger or OpenAPI. And that's also for documenting these APIs to other developers. And if I look for the customer business entity, I would see them here. And as part of the documentation, we also see various query capabilities. So I could use this interface also to specify how many records I want, which fields I want to have returned, and I could also filter on some of these fields. So if I go into tryout mode, then I could say, well, give me 5, and the fields I want to see custom, name, city, country, sales rep, and I want customer number 5, and I execute this query, and I'm getting the response. I get the fields that I want. I would get a maximum of 5 records, but there's only one with that customer number, and so this provides a very flexible interface all around the business entity that has been generated using the business entity designer. I'm going to use that business entity in a couple of minutes also for the foundation for a front end. But let's continue with the presentation. I said it earlier, we are in the process of porting that tool into the browser. It's not yet fully functional, but it's getting there. So as a portal or desktop for developers, we provide various tools. We're also porting the UI repository designers into this tool. But for the business entity designer, I could actually open the same business entity here, but I can also just take tables from the database and drag them there and basically have a very similar designer experience here than we have on the desktop. And the backend for this is also PassOE. The code generation would be happening on PassOE and then would be integrated with build tools for compilation and eventually build Docker containers, etc. out of this. Good. Let's look a little bit at front ends. So we provide a couple of front ends as part of the framework, and we provide lots of options for integrating with other frameworks. The front end that we provide is one is for the Windows desktop based on OpenEdge GUI 4.net. GUI 4.net was provided or introduced by Progress more or less 15 years ago and allows to use .NET desktop controls as part of the Progress GUI client. And even for customers that are aiming to go to the web, that might be an interesting intermediate step. We do have customers that say in whatever time frame we want to have a web application. And in order to get there, we know that we need to make a very hard cut between front end and back end. There cannot be any front end in the business logic, so this tough work needs to be completed. And in order to provide the user a nice user experience, with what we do with some is we modernize the business logic so that it can be executed on the app server. And at the same time, we provide more modern desktop front end that integrates in the same client with the existing application. No modernization happens overnight. Modernization is always, depending on the size of the application, a process that takes months or years. And when you can do that within one client application, and some screens suddenly have a better architecture, but also nicer UI, then that increases the user acceptance. If we would start with some web-based screens, and then we have the GUI application and web side by side, and the users always have to change between the browser window and the desktop application, that doesn't make the typical user very happy. So we have some customers where a modernized both from the appearance but also from the architecture desktop UI is an intermediate step on the way to a web application. And we also have customers that say, we don't see ourselves in the browser in the next couple of years. We want to have the richest experience on the Windows desktop. And for that, the .NET framework is just a very good solution. I'm not saying that you cannot have a rich experience in the browser, but it's definitely easier when you're targeting for the Windows desktop to do that using desktop technology. Also, things like interfacing with local resources. I mean, printing in the web is always very complicated. Printing on the desktop is something which is which involves much less complexity. But we do web applications too, and I'm going to show that soon. We have mobile applications. We're using NativeScript. NativeScript is a JavaScript or TypeScript-based mobile development environment that used to be part of Telerik. So it used to be a Progress product. I think 2 years ago or a year and a half ago, Progress passed on the control in this open source project to a company that has been doing lots of projects using that. What's the name of the company? NStudio, I think. NStudio. That hasn't changed a lot in the support of this product, and so we didn't see a need to switch to a different mobile development tool yet. Yeah, there's the other UI technologies in the .NET framework. Razor, Blazor allows you to build applications that both run in the browser and on the desktop and various operating systems. We provide open interfaces with customers that used our RESTful interfaces to build their own browser-based clients, maybe because they wanted to integrate the backend into a browser-based application that they already had or that they used for other application as part of a larger enterprise. We do have some customers that build fully headless applications. One of our customers is using the SmartComponent Library to control an automated warehouse. So whenever a parcel runs on the transporter belt and comes to a switch and we need to decide whether it goes left or right, it's basically a request to the SmartComponent Library, and no human user will ever see a front end of the SmartComponent Library. So that's also possible. And we have partners that build their own user interfaces. One of them is Build One. They're here, present here as well. They use a lot of our backend under their own front-end components. That's a desktop UI. What I want to do is I want to build a very simple browser-based UI like this. That is our standard look and feel for browser-based applications, but that's just a template that we provide. Everything you see here, either by integrating custom components or just by changing style sheets or other configuration files, can be fully customized. I mean, starting with the arrangement of things, colors, fonts, whatever, different images. We can build the application menu using whatever style of components you want. Customizability is very, very important for us and our customers here. And to quickly build UI components, we can actually start in the business entity designer. So I have built a business entity earlier, and using tools in the toolbar or in the ribbon, I could create components in our repository database. And the repository database is one way how we could design UIs. We support UIs that are basically built in code of whatever is the target platform. So we could start in whatever Angular development tool. Most people would be using Visual Studio Code, and also design UIs there based on HTML templates. And that's probably how a web developer would want to tackle it. For more an OpenEdge developer, I believe that a what you see is what you get approach. What you see is what you get approach is probably more desired. And a very fast way is to use the wizards that we provide here. I start by defining a data source. A data source just defines the link to the business entity, the backend component. And then I can create a viewer. I refer to that business entity as just pick a couple of fields that I want to see in the viewer. And I need to give it a unique name. I can use this to create a grid. It looks pretty much the same as with a viewer. And pick some fields. And then I can create a form, and the form puts together, or in the form we can put together the components that we created earlier. And make some other definition. It's just a starting point, and also that needs to have a unique name. And after I've used the wizards to create the starting point, then I would go into tooling, which currently is available only on the desktop, but Also there we're working on a browser-based variant. I go into a designer tool. And that is a structured view on that. The goal is to define or develop a UI definition that can be used in all three UIs that we provide, so on the desktop, in the browser, and on a mobile interface. So it is abstracted, but we see that we have instances of the components that are created earlier, the viewer, the grid, and the data source. We have links between them, so the simple screen, there's only one data source that's used, but there could be multiple, and then the linking is quite important. I can use this tool to directly start the form, and when I run it, it is immediately functional. It's not nicely arranged because we just said, okay, select these fields, and I could be going into a graphical designer to make that look nicer. So if I look in the list of instances, for instance, I would be opening the viewer, and then on the design tab we have a graphical representation. What we see here already is on the country, for instance. The country is a field that we have registered in the framework earlier as a field that should by default be represented with a lookup, because there's a table behind it, and probably whenever we use the country field somewhere, the lookup makes a lot of sense, so it's a good starting point. I could be dragging around the fields. We provide a similar developer experience here than developers would be experiencing the Microsoft Visual Studio on the Progress Visual Designer with all these snap lines. I can start the screen straight away from here on the desktop. I think I did that before. And if I go into the browser, into the application, then we could have that screen appearing on the menu here, but I haven't added it to the menu yet, so I use a dynamic tool to launch it by its name. It's something that typically isn't available to users. Let's search for it. And run it from here. And now we see basically the same screen in the browser. I see the lookup here. This is now using a responsive layout. So if I make the screen smaller, we should be seeing that the screen wraps. Or maybe I need to enable that before. We have the lookup, which provides selection of the country, and that's actually a fully working web screen. I could use it to edit data. It uses the validation in the business entity if we implement that, and yeah. When we build screens like that, most screens will need also some front-end logic. So many applications cannot do without. Unlike other frameworks, we have decided not to try to use ABL code running in the backend to control the front end. I believe that an Angular developer knows much better how to control an Angular front end than any ABL developer can do. There's certain things, like just enabling fields or so, which you could be doing from ABL code on the backend quite easily, and we support that too. But we also want to provide the full flexibility to write front-end code in the target environment. We also make it very, very easy to build custom components based on whatever Angular controls you want to use. What this does is it's subscribing to a state changed event. or a value change event of certain screens. And then actually that would be code that we would be writing to change the enabled state of the state field based on whether the country is USA or not. That's typical client logic that we use in our examples. Most European countries don't need the state field, so then we would be disabling that. We provide so-called facades to the UI components to make it a little bit easier also for an ABL developer to do this. We name the properties there like in the ABL, but this is actually TypeScript code that would be integrated in the browser-based application. Good. Back to some other aspects. So the application framework mentioned it earlier. Many features there. Authentication, authorization, very important. We can authorize everything that users see or could be using, starting from menu, toolbar buttons, access to business logic, custom tokens. We can use our authorization against application data, so maybe users would have different rights based on the region being something in the application database and not something that we define. Localization is there. We provide definition-based referential integrity. So we've seen that for the country field, we automatically provide a lookup that's part of the same definitions that we would also be using for referential integrity. So we could be doing cascaded deletes or delete restrict or delete nullify and all these kind of rules. We can just define relations and then automatically validate key values and stuff like that, all aimed to reduce the amount of code that developers would have to be writing. We have a batch scheduler that supports all the repeating patterns you could think of, every first Monday the week, or every first Monday the month, or the last day of the year, or relative to public holidays, repeating or run once. The batch scheduler is also our preferred environment to run long-running jobs that you just need once, like a long-running report. The app server isn't the best tool for that. The app server should be available for interactive requests that return ideally sub-second or in very few seconds. You should not abuse an app server to run a report that runs half an hour to build it. So that's something where we provide a batch scheduler for. Makes it nicer to monitor the requests and yeah, also to distribute the load on different systems. Yeah, security features. We basically support everything that PassOE offers. We integrate with the security features of PassOE and others. Yeah, the framework, most of the tooling is written in the ABL. Well, nearly 100% isn't really true. When we release the browser-based version of the Business and Designer and the repository tooling, the quantity will go down, but we try to do as much as possible in the ABL. We ship the full source code to our customers. We have almost weekly a release. We will not have a release this week because I just won't have time to write release notes. Yeah, well, we have a support strategy for the LTS releases and always the most recent new feature release. I need to update this slide I've seen because 12.5 is there and soon there will be 12.6. So let's look about options for migrating applications. That's something that over the time we've always spent a lot of time into that. We are I'm not going to try to convince you that I have a full automatic button that takes whatever GUI application and overnight makes a browser-based application out of it. Yeah, we have quite some capabilities for semi-automation. And no matter how long a migration from TTY or GUI to maybe a distributed browser-based application takes, even if you just speed it up by 10, 20, or 30, or 40%, that's already a lot of time that you save. And depending on what your application is written in, we can do much, much more. We're currently in the estimating phase for a migration of an DWP-based application. For a majority of the screens, we're almost getting to 100%. There's some screens where the old framework has been abused and things is happening in places where they shouldn't be happening. That always makes our life complicated, but just API to API mapping and hook to hook mapping and some code conversions is actually possible. And well, we're getting better and better there with every project. So as part of the tools that we provide, we can analyze existing code. We use a code scanner there called ProParse. ProParse is open source. There's a couple of companies in the community maintaining this. We're one of them. Migration goes much, much better when we are able to identify patterns. One example of a pattern would be a lookup. So when we look at a screen and we see a text box, a button, and a disabled text box, that smells so much like a lookup that during the migration, we wouldn't be replacing that with 3 individual fields. We would be replacing that with our lookup component because we recognize it, and that makes it much, much more powerful. We can discover relevant business logic. If we look at a GUI application, there's a lot of code, even if it was not built using a framework, that is not needed anymore because it's standard behavior in our framework. So we can try to filter that out. We are able to merge business logic that we found in multiple screens if it used with the same database table out of multiple screens into a single component to have a better reuse and make it easier to reduce redundancy. Redundancy is actually the biggest enemy in trying to be efficient here, because when you have the same business rule in various places, seeing in an automated way that it's actually really the same, that's difficult. And sometimes it's just 95% the same, and then, yeah, no tool can ever decide on the things which do not match what is the right one. We have used that successfully with various well, I call them legacy developer frameworks like Progress Dynamics, ADM1, ADM2, DWP framework. We're in preparation with a customer in Belgium on a ProShield migration. All those are frameworks that had been actively used in the past but are no longer. But we can do the same also with an application which has not been built on a framework. And I want to show that to you based on this screen. We have a tool to make it a bit more visible. And the tools that we see here, they're really showcase tools. When we do that with real customer applications, we don't waste time in making a pretty UI on top of the tools. It's just we run procedures and they go through the code. So what I can do here is I can open that screen that we had on the screenshot, and it reads the source code. We're not running the screen in the background and going through the widget tree or whatever. It really reads the source code, which has the benefit of it works equally well with TTY and GUI applications. We couldn't be running a TTY application in here because it would be a different Progress runtime. And we couldn't run all the screens because, well, maybe there are shared variables and input parameters and all that stuff. So we read the source code. And what we see here is a tabular representation of the components that we found here. There's some pre-selection of components that we by default filter out. So here we understand there was a lookup button, or there were 2 lookup buttons. We don't want to have them. I can open the screen from here in Progress Developer Studio so that we can look at it in the app builder. There are, we need to find the outline view, 2 frames. And I want to focus on the frame for the shipping address. This here, I have prepared a little bit. So if I start the screen from here, I can see the list of customers, and I open customer number 5 because he actually has some shipping addresses. We see a web application that looks pretty much like the one that we've seen in the app builder. On the list of the shipping addresses, we currently only have the browser because I only migrated so far. So what I want to do now is I want to go into this tool, and there's the second frame for the shipping addresses. And using a simple wizard here, I want to turn it into a viewer definition in the repository. It proposes a name based on the app builder file name and the frame, but I could provide a more meaningful. It has found a data source in the repository that provides the same data that is used here, so it's basically the ship2 table. There are other wizards here that allow me to build a business entity, not from scratch in the business entity designer, but a business entity that provides exactly those fields and can contain then exactly the same validation rules, etc., etc. So when I generate this screen component, I can then open the whole screen. It's another instance. We see we barely have the 4 big components, the window itself, the browse, the customer, and the shipping address frame. So I open the window, and on the list of instances, the shipping address frame is not yet there. We haven't seen it. So I'm just going to add it here. That one, I put it on the second page. I put it next to the browser. Save it. I hook it up to the same data source as the list of shipping addresses. We have that already. Does that? The data source was actually created automatically for me. Good. So I could run the screen now also here on the desktop. I see the grid, and I see this viewer here. And I can even run it in the browser. All I need to do is I need to trim the app server to make sure that all the caching, if you build repository-based UIs instead of code, caching is key. So I need to reset that cache now by trimming the app server agent. And when I now do a reload, and I search for customer number 5. Oh, why am I not seeing it? There, it's below. Okay, because it probably doesn't fit there. So, and that's a responsive layout. We're not doing a pixel perfect transition here by default because more and more people want to have responsive layouts. This is a pixel perfect one where the fields are actually exactly positioned where they were. So we have both options for these frames, whether to use pixel perfect or not. Screen layout is not the only thing. The other component is actually code. So I'm going back into the tool here. And as part of the screen, there's also typical leaf validation, just as one example. So I open that in a different tool from here, where we actually see the abstract syntax tree behind, and I can navigate to some of the trigger code, for instance. And if you look at that, that's actually, again, the similar business rule. Customers in the USA need to have the state field, etc., working with the Progress GUI. And one of our showcase conversions here is turning that into validation that we can put into a business logic component on the app server. And if I put the two pieces of code side by side, then we see here left the original code, on the right-hand side is the migrated code. So we turned it into a validation method. We look at fields now of the temp table. There are the matching fields there. If there would have been name matchings that would have been applied. Instead of direct UI output, we use one of our APIs that makes sure that the error message is shown on the screen. If I look at something like this, where I'm looking for a record in the database and showing then values of that in the screen, we see that that code has also been transitioned, and there are just some of the more simpler transitions that we can do with code. The decision points, so looking at the record, and if available, that has been the same. So we basically just change where we're interacting with data coming in from the screen or sending data back to the screen. This is using access to a database table. Depending on the requirements of the customer, we could also replace that with an access to that table through a business entity. Just a little bit more changes to the code. And I could now copy and paste this into the business entity, and then we'd be seeing that the business rules, the validation, would work within that screen. Good. Unfortunately, I don't have enough time to show everything, so I'm going over it. We can do the same. I have another sample where we do that with a TTY application, whether it's GUI or TTY or update editing or more event-driven, really doesn't make any difference. I said in the beginning, we have scheduled another training for the SmartComponent Library done in cooperation with Progress Software. Registration for that is done through Progress Professional Services in Rotterdam. Crystal Philipson is the person to talk to. We can help you with that too, just if you want to know more about the SmartComponent Library. If you have questions after this presentation, either meet us at the booth or email us with questions on info@consultingwerk.com. And with that, I would like to thank you for your time. Afraid I can't take questions here, but let's take them outside with a coffee.